we are going to solve this radical equation. It says if x root x minus 11 root x equal to 10, find x minus root x. So this is a radical equation. Please, if today is your first time of coming across my video, kindly follow this page for more educative content, and also do well to like, comment, and share this post. Okay, now what we are going to do, because of this constraint, the radical, so we need to get rid of this radical. How do we do that? We can only use substitution. So we use substitution. We say let's go to solution. Your solution, we say let any alphabet. So we need to substitute for square root of x. We can say let y be equal to the root of x. So that from here, it will now imply that x equal to y squared. Okay, so x is equal to what? Y squared. Now we are going to substitute this for x into the original equation. So when we want to do that now, whatever x is, we are going to replace it with y squared. Okay, so substitute back into this equation. Okay, substitute back here. We're going to have here becomes y squared. So in place of this x here, we have y squared multiplying the square root of x is also y squared. We're having the root of y squared now minus 11, then multiplying the root of y squared equal to 10. Good. And remember, whenever we have the root and the square, so the square will cancel out the roots. So here it will become y squared multiplying by y, then minus 11 multiplying y equal to 10. So that we can have y cubed minus 11y. Now take this 10 to this side, minus 10 equal to 0. So here we have formed a cubic equation. So we need to factorize this. And how do we factorize this? So we are going to be testing for the factor. If we test for y, let's test for y equal to 1. If you test for it, substitute it into here. If at the end of the day it gives you 0, so it will mean that what? Y minus 1 is a factor. Okay, so let us test for that. 1 into the, so here it gives us 1 over 3 minus 11 into 1, then minus 10. Will this give us 0? This is 1 minus 11 minus 10. So this does not give us. So this does not give us. So therefore, y minus 1 can't be a factor. Now let's try y equal to minus 1. So this will be y plus 1. So let's check minus 1 if it will work. So if we plug in minus 1 here, it's going to be minus 1, let's do power 3, then minus 11 into minus 1, okay, then minus 10. Let's check if this will give us 0. We're having minus 1 cube is minus 1, minus 11 times minus 1 give us plus 11, then minus 10. So automatically it becomes 11 minus 11, so which gives us 0. So therefore, y plus 1 is a factor. So if we use this one to divide this one by polynomial division, so let's all use this now. We're going to use what is called synthetic division, okay? I'm not doing this for learning's sake, okay? So put y plus 1 here. Now we have a y cube minus 11y minus 10. So let's go. So take this y here to divide this y cube. It will give you y squared. Put it here, y squared. Then multiply the whole of this by the y squared gives us y cube. Y times 1 gives us plus y squared. Okay. Now, let's subtract. If we subtract, this one will be gone. Then here get y squared. So what we have now, we'll bring this down, gives us minus y squared minus 11y minus 10. So let's bring it down. Now let's divide here by this to give us minus y. Okay, to multiply it by this gives us minus y squared, then minus y. Now let us introduce minus. Okay, we are going to subtract now. If you put minus, this will turn to multiplication, this will turn to addition rather, and this one also turns to addition. So this one and this one will be gone. It will now give us minus 11 plus y. Now let us divide now. Y goes into minus 10y to give us minus 10. Okay. Now let us multiply this by minus 10. Multiply y plus 1 by minus 10. This gives us minus 10y. Minus this one times this will give us minus 10. Now let us introduce minus. If I introduce minus, here becomes positive, here becomes positive. So everything at the end of the day gives us 0. So therefore, we have y plus 1. Then this is the factor here, become y squared minus y minus 10. Now equal to 0. So we can then say y plus 1 equal to 0, or y squared minus y minus 10 equal to 0. So in that case, y here equal to negative 1. Then we solve this one again by quadratic formula because this cannot be factorized. So therefore, we will ignore this value as y is extraneous. And remember that we said that y equal to the square root of x. So if y is negative 1, it means it's an extraneous value. So we ignore that. We then solve this one by what? Quadratic formula. So we have a y equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now what is your a? A is 1, b is minus 1, okay, and c is minus 10. So we have y now equal to minus into minus 1, okay, plus or minus the root of minus 1 all squared minus 4 into a is 1, c is minus 10, okay. Now this minus 10, everything all over 2 times 1, okay. Now what we have is going to give us here minus times minus gives us 1. Y here becomes minus times minus here is 1 plus 1 plus or minus the root of 1 square is 1 plus 40, okay, everything over 2. So now let's go. We then have y equal to 1 plus or minus the root of 41 now all over 2. So that is the value for y. But now y must be greater than 0 for us to satisfy, must be greater than or equal to 0. That is what the expression gives to us, the equation rather. So y must be greater than or equal to 0. So therefore the one we are going to take, we will not take a negative value. We're going to take y equal to 1 plus the square root of 41. Integral problem, okay? We are asked to evaluate the integral x raised to power 5, then square root of x raised to power 3 plus 1. All right, so this question looks difficult anyway, but don't worry, we are going to dismantle it with substitution method, right? So where we have constraint is this x raised to power 3 plus 1, okay, because of this radical here. Now we are going to let u substitution. Let's go to solution. We say let u, okay, let u equal to what we have here inside the radical. We call x raised to power 3 plus 1. Then we are going to differentiate with respect to u, x rather, differentiate u with respect to x, so that we have du dx equal to 3, multiply x by 3, then take away 1, becomes 3x raised to power 2. We need to make the x the subject of the formula so that we can substitute for this dx here in this expression. So here we can cross multiply, or simply take a reciprocal so that we can have a word. Let's just cross multiply. If I cross multiply, I'm going to have 3x squared dx, okay, equal to du. So that you leave it like this. If you leave it like this, no problem. Or you can as well say dx equal to du over 3x squared. You leave it like this, no problem. We are good to go. Now let us come here to this integral, right? I also want you to look at one thing here. In this u, in the first place here, where we let u equal to x raised to power 3 minus 1, we can decide to make x raised to power 3 here the subject of the formula. But wait, let's go to our evaluation. So if the case leads to that, we are going to do that. Now let's come to this our integral. We know that in this point here now, it will become x raised to power 5. Then the whole of this here is u, okay, become the root of u. Then where's our dx? The x is now du over what? 3x squared. So it becomes du over 3x squared. Good. Now let us go into this. We are going to take this x squared, we cancel here. We are going to remove 2 of it from here, okay? So it will now give us x raised to power 3 here. It will now give us the integral x raised to power 3, because this x squared is already cancelled out from inside x raised to power 5. Then remember that u here becomes raised to power 1 over 2. Then it becomes this du becomes du all over 3. Good. Now we are proceeding. We still need to substitute for x raised to power 3. We need to get rid of this. So we want everything here to become u. So what we have here can be written as this. To first of all take this 3 away. Let's take it here. It can become 1 over 3. There the integral. We have x raised to power 3. Then u raised to power 1 over 2 du. Good. Now let us go to, in this our original